Okay, today's lesson is 4.1, graphing quadratic functions. And I want to start off and say I'm really sorry I'm not with y'all guys and girls. And I'm going to do my best to make this easy for you. And if you have any questions, ask one of those other brilliant students in your class, because I know they can help you. But anyway, or you can email me with questions. All right, so to start off with, a quadratic function, any function whose greatest exponent is, and I did not get this ready like I normally do, so bear with me here. All right, any function whose greatest exponent is 2 is called a quadratic function. F of x equals ax squared plus bx plus c, where a is not 0, because then of course we wouldn't have that term. But ax squared is referred to as your, I have to make this a little bit smaller or it's not going to fit in my blank. Okay, that is our quadratic term. Bx is your linear term. And c is the constant term. Constant, of course, because there's no variable, and therefore it doesn't change. The graph of a quadratic function is called a parabola. And you know, we've talked about this before. Okay, parabola being that U-shaped looking thing. Okay, so the graph of a quadratic function, we just said, is always a parabola. And here is our equation in standard form. The y-intercept is always c, 0c. So that's why that's something that's important about this form versus the other forms of quadratic. The equation, keep in mind it is an equation. The axis of symmetry is x equals negative b over 2a. And the x-coordinate of the vertex, of course, is negative b over 2a. Now, one of the things that I will tell you that all my years of teaching that I have found people have more success with is, and really what we're trying to do for y'all is for you to be able to recognize an equation and know what the graph of that equation looks like. So whenever you see that, you know it's a quadratic, you know it's going to be a parabola, then you find, of course, a parabola, the important place that you've got to know is your vertex. And after that, know these key points. Okay, so the vertex, when I talk about this part right here, these are the key points that are going to describe a rate of change of your parabola. This might be different from what you have heard in the past. I think we've talked about it this year already, but just in case, this is to reinforce. These are the key points of the parent function y equals x squared. I know we've talked about this, but anyway, your vertex for that parent function, and I put parentheses around it to label that vertex, is 0, 0. And our key points are, if we pick 1, 2, and 3, and of course square each of those numbers, then you have 1, poo. Don't do that to me. 1, 4, and 9. Okay? Those key points I'm going to refer back to as we go through the section. So just keep that in mind. Okay, so in our graph right here of a parabola, this dotted line, of course, y'all know is your axis of symmetry. Okay, on the left side, this point here is your y-intercept. That, of course, is 0c. And what they're doing here is reminding you this axis of symmetry. When you find one point, you always know one on the other side, which is kind of what these key points are. So this is the reflection of the y-intercept. Okay, and the bottom point, which of course is critical and what you always need to know of a parabola when you're asked to graph it, and that is the vertex. And as I mentioned up here, the x-coordinate of that vertex is always negative b over 2a. And how do you find the y-coordinate? Anytime you know x, you just plug it back in, which is why it's written like this. F of negative b over 2a, because you plug it back in to find out what the corresponding y value is. Okay, Every parabola is U-shaped, which means it's either going to be going up or down. Okay? If it opens up, it has a minimum value, and that is when A is greater than 0 or positive. It will have a maximum value when A is less than 0 or negative. So in this particular one, A is positive, and over here, A is negative, because we know it's going down. All right, let's go back to that if A is positive, right here is my vertex, and my vertex will be the minimum value. Over here, it will be a maximum value. And the y-coordinate, this is the thing, that's the minimum point on your graph and the maximum point. The y-coordinate, and this kind of confuses people, the y-coordinate in this particular graph is referred to as the minimum value. And a lot of people tend to get confused or forget that the value of a function is only the y-coordinate. So keep that in mind as you're going through. Over here, of course, the y-coordinate is the maximum value. Okay, to graph these things, you always have to start off with finding the vertex, which we just said, negative b over 2a, comma, f of negative b over 2a. Now, when you find that, if that point is not a fraction, the most efficient way of graphing is to plot using, that doesn't look like the word I wanted to write, plot using a rate of change. Okay, rate of change, or, I want that right, rate of change. Those key points that I just talked about earlier. Okay, now if you do get a fraction, you can still use those key points. I do think it's easier, but some people don't feel comfortable with that. So it might be, you might prefer to go graph the y-intercept and then use a table of values. And you don't need to, depending on how many points you need to find, I just like you to fill up the graph. Okay, so let's do a few of these and look at them. So if we have negative 2x squared plus 8x plus, minus 3, then let's try something different here. Sorry, I wasn't set up earlier. Okay, so to start off with, negative b over 2a is going to give me negative 8 over 2 times negative 2. And that, of course, is 2. And then I'm going to go plug in g of 2. And g of 2, when I plug that in, we've already done that a lot. That, of course, is going to give you 5. Why did that happen? Sorry. So that makes my vertex 2, 5. Okay? Now, the difference here that you always have to pay attention to is that your a value, well, actually, I'll come back to that. Vertex is 2, 5, not a fraction. So my key points are 1, 2, 3, 1, 4, and 9. Now, the thing that you have to pay attention to is what a is equal to. In this case, a is equal to negative 2. That changes the y values. You still have 1, 2, 3, but I have to multiply each of these y values by negative 2. So 1 times negative 2, 4 times negative 2, and 9 times negative 2. Now, you don't have to plot all of these. Why did I pick that? Oh, yes, negative 18. My bad. Because I'm taking times negative 2 times negative 2 times negative 2. Okay, so I'm going to go plot the point 2, 5. 1, 2, 1, 2, 3, 4, 5. And this is my rate of change. So if I go over 1, I'm going down 2 in both directions. If I go over 2, I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And the nice thing about this is that point right there is your y-intercept, which is negative 3. which you can check right there and know that you're doing things correctly. And then I'm going to plot that one, and negative 18 is going to be off my graph, so I am not going to connect it. So I'm going to pause for a second so it doesn't look like a crazy thing and graph it, and I'll be right back. Okay, let's look at the next one. We have 4x squared minus 8x plus 1. So again, my negative b over 2a is going to be 8 over 2 times 4, which of course is 1. And when I plug 1 back in there, okay, you're going to get negative 3. 4 minus 8 plus 1. So that makes my vertex 1, negative 3. Again, not a fraction. So I'm starting off with 1, 2, 3, 1, 4. I gotta figure out why it does that. 1, 4, 9. Now I gotta look at that a value, and that a value is equal to 4. So if it was equal to 1, then I just plot those points. Okay, but that means every one of my y values is going to change. X doesn't change. 1 times 4, 4 times 4, and 9 times 4. So clearly I'm not going to graph all of those points. I'm only going to graph what's on that will fit on the grid. If you want to renumber your graph, y'all, that is absolutely fine. You may do that. Okay, so 1, negative 3. And if I go over 1, I go up 4. 1, 2, 3, 4. Again, another checking point. That's my y-intercept. That matches with my equation. This is going to be a real skinny graph. If I went over 2, I'm going to go up 16, which is off my graph. So again, I'm going to pause so you don't have to watch my ridiculous drawing. Okay, so I hope y'all can see how much easier that is to graph because you're not calculating a bunch of information. All right, moving on. Maximum or minimum values. Consider the function that we have. Come on. 4x squared minus 24x plus 11. Determine whether the function has a maximum or minimum value. Okay, I hope y'all have already decided it's a minimum value. Why is it minimum? Because a is greater than 0. A, of course, is 4 in this problem. State the maximum or minimum value, okay? And this is that key thing here. They want the value. That means that is the y-coordinate of my vertex. So that means I've got to go find my vertex, negative b over 2a, and that's going to be 24 over 2 times 4, and that, of course, is 3. And then I'm going to go plug in f of 3. F of 3 is 4 times 3 squared minus 24 times 3 plus 11, in case anybody forgot. And that, of course, gives you negative 25. So the minimum value of the function is negative 25. Golly, I'm going to just... Okay, state the domain and range. So I hope you can do this without graphing, but to give you a little visual, help you understand. The parabola goes up, boom, and the minimum point on that parabola we just figured out was 3, negative 25. Okay, the domain for every quadratic function is all real numbers. You can write all reals. You can write negative infinity to positive infinity. You can write the fancy little r, whatever you want. The range, okay, if this is a minimum, then that means that it is the lowest point on my graph. And actually, it's equal to that. So we would have a bracket, negative 25, comma, all the way to positive infinity. Okay, word problem. Suppose a different tournament that Eddie organizes has 120 players and the entry fee is $40. Each time he increases his, you can't read that, can you? Each time he increases his fee by $5, he loses 10 players. Determine what the entry fee should be to maximize the value of the pool. I'm going to do this using a quadratic equation. Some of y'all might be able to figure this out because you're so much smarter than I am. But to help you understand, you're basically trying to figure out how many increases I need to get the maximum value. Okay? And that's something we do a lot with quadratic equations. So I'm going to define my variable x as the number of increases, how many times I'm going to increase the fee. So my function p of x for the value of the pool, let's go with p, doesn't matter what you want to put, okay? But if you're trying to figure out, you're organizing, he has 120 players and the entry fee is 40. So how much money he's going to get is, of course, 120 times 40. However, if the entry fee is 40 and he increases it, okay, each increase is worth $5 to him. He has 120 players, but he loses 10 players for each increase. So this is what you have to start with. That's the money. And if I increase it, my money is going to increase, but I'm going to lose the number of players. Okay. Now, to determine the entry fee, you're looking for that value of x and you want to know how many increases. One of the things to remember about a quadratic equation, if you don't know already, is you can, you're trying to solve that equation for x, and you can go multiply it out and then use all different methods of solving it. However, one of the things to remember that's very, very important about quadratic equation is that your vertex, which is going to give us that maximum value, is always halfway between your zeros. Okay, so it's going to be easier to solve this problem by taking each of those, setting them equal to 0. So when I set that equal to 0, I'm going to get x equals -8. When I set this equal to 0, I'm going to get x equal to 12. Those are my zeros. All right, what's halfway between? Need a little more room. Okay, halfway between means I'm finding the midpoint. So -8 plus 12 divided by 2 is, of course, 2. So my vertex, that is the x coordinate of my vertex. All right, and how would I find out what the y coordinate is, which is going to be my value, is I got to go plug that back in to that equation. So I'm looking for p of 2, and p of 2 is going to give me, what, 40 plus 10, and then 120 minus 20, which is 100. And that, of course, is 5,000. So what should the entry fee be to maximize the value? So your maximum point, the vertex of this parabola, is at 5,000. Okay, so x is the number of increases. That means I want 2 increases. So what is my entry fee going to be? 40 plus 5 times 2. So my entry fee will be $50. Okay, I like that problem. Okay, next thing, 4.2. And in 4.2, we're talking about solving quadratic equations by graphing. And the very, very important thing, one of the things you got to understand about quadratic equations and what we're doing in this chapter is that you have the same concept by different names. Okay? You're not there yet, but at some point you will. But I myself, I'm the same person, but I am named a teacher, a daughter, a sister, a mother. Okay, same concept, different names. So that's what's going to happen in quadratic equations, and you got to pay attention to what the question is asking, because it's asking the same thing in different ways. For example, the solutions, when we talk about the solutions, also known as the roots of an equation, then we have an equation, ax squared plus bx plus c equals 0. This is what we call an equation. All right, and our roots are x equals, you can say root 1 and root 2, just to represent some number. Okay, the other way, if you look at these right here, we don't call those roots, we actually call those, they are how you write the x-intercepts. also known as the zeros of a function. I think you've heard that before. They're the zeros because y is always 0. Now, as I just said, x-intercepts and y. That means it's not an equation anymore. It's a function. Ax squared plus bx plus c equals y, or f of x. Either one. But the point is we have two variables, and it's called a function. And then last but not least, we have something that is called an expression. And I know y'all already know this, but basically, if you know what the roots are, then you know that these are the corresponding factors. Not x1, excuse me. X minus r1, x minus r2, and those are the factors of the expression. So you're going to see that, hear that a lot as you go forth in algebra in high school. All right, so in these problems, when they say solve by graphing, okay, the important thing to realize, and I kind of want you to know, is that you can always use a graphing calculator to solve a quadratic equation. So while this may be a simple problem, okay, help it to understand the concept. When you're solving by graphing, then you are replacing 0 with y on a calculator or a graph, okay? So in that aspect, if I wanted to do negative b over 2a, then I have, what is that, negative 2 over 2 times 1, and that, of course, is negative 1. And then when I put negative 1 in here to go find out the corresponding y value, I'm going to get 1 minus 2 minus 15, which is minus 16. Now, let's go by 2s. I'm going to go by 2s because I got to make a point here. So I'm going by 2s on my y-axis. I'm still going by 1s on the x-axis. So my vertex is negative 1, 2, 4, 6, 8, 10, 12, 14, 16, right here. Okay? A is equal to 1, which means it's really easy. 1, 2, 3, 1, 4, 9 to plot those points. Because I'm going by 2s, I'm actually going to go with this one at first. So if I go over 2, 1, 2, I'm going to go up 4, 2, 4, which is right here. 4. If what I say, over 2, up 4. Okay, if I go over 3, I'm going to go up 9. Actually, and let's go to another one. Y'all should all know how to do this. If I go over 4, how much am I going to go up? 16. So 1, 2, 3, 4. I think 16 actually puts me right there, doesn't it? Okay. Solve by graphing, which means I'm supposed to graph it, and I don't want y'all to watch me this ridiculous. So pause. So I hope you noticed that when I was graphing that I'm using the points that are easy to graph from my rate of change. But more importantly, okay, when it says solve by graphing, that and that is where my solutions are. So I only have one variable, which means it's an equation. Variable is x. So what are the solutions? X equals negative 5 or positive 3. Now, don't be yelling at me because you're like, I could have factored that and already done it. The point is for you to understand where the solutions are when you see a graph. Okay? All right. X squared minus 8x equals negative 12. Of course, we first off, let's change, have to set it equal to 0. So that gives me x squared minus 8x plus 12 equals 0. If I do my negative b over 2a, then I'm going to have 8 over 2, which is 4. And when I plug that back in, then I'm going to get 4 comma negative 4. Okay, so 1, 2, 3, 4, 1, 2, 3, 4. There's my vertex. I know it's going up. A is equal to 1, so I got these same key points. So I'm going to go over 1, up 1. And for what it's worth, you didn't really have to graph that, because if I go over 2, I'm up 4. And there is, and you're not going to worry so much about it. But there's my graph. More importantly, this and this is the answer to the problem and the solutions. So x equals 2, or 6. Okay, that's what I'm looking for most importantly when you're graphing these things. Okay, a concept that you should be familiar with, but let's reinforce it. Every quadratic equation has at most 2 solutions, and you can always see it from the graph. Where does it cross the x-axis? So in this case, we have one solution. Here I have 2 solutions, and here I have no solutions. And we're going to get into that and what it looks like algebraically on not in a later lesson. Okay, but that's where the solutions to your graph are. So turn the page. We're almost done. Find 2 real numbers with a sum of 6 and a product of negative 55, or show that no such numbers exist. So the sum, I have 2 real numbers. That means I got x and, well, you can do x and y, but I'm going to do x, and if the other one is, they add up to it, then that means this is going to be 6 minus x, and that equals negative 55. There's my quadratic equation. If I multiply that out, I'm going to get 6x minus x squared equals negative 55. I am going to put that in standard form, which means I'm going to put x squared first and make it positive. And that's going to give me x squared minus 6x minus 55 equals 0. We're going to factor this because that's going to be an easier way. X minus 11, x plus 5 equals 0. And so the 2 numbers that I have are, of course, negative 5 and 11. If that was too fast, email me. Okay, because really what I want to talk about this is kind of a very important concept. Okay, estimating solutions. Often exact roots cannot be found by graphing, so you estimate them by stating the integers in between, state the integers between which the roots are located. Okay, so what you are looking for on your, come back here, sorry. Okay, what you're looking for in your table of values is you're looking for a change in the signs. Okay, so this is positive, this is positive, this is negative. There's a change. I went from positive to negative, so there has to be a 0 in between these 2 numbers, between negative 2 and negative 1. That one's negative, that one's positive, positive, positive. They change signs. Again, there's a 0, and that means there's a 0 between 0 and 1. All right, I got to pause 1 second. Okay, so on these last 3 problems, all right, this says to estimate the roots. Solve x squared minus x minus 10 by graphing. Okay, and well, we haven't talked about factoring yet. So if exact roots cannot be found, state the consecutive integers between each between which the roots are located. Sorry, clearly having trouble reading. So to graph, I've got to find that vertex. So I'm going to do negative b over 2a. And that, of course, is going to be 1 over 2, which is 1/2. Ooh, I got some fraction. And when I put 1/2 back in there, I'm going to get negative 10 and 1/4. So to graph this, I have 1/2, negative 10 and 1/4. So that's down about right there. Okay? And this is what I'm saying. You can either choose to do, we do know this point, negative 10 is my y-intercept. That was kind of one of the things I was telling you. So if I went half that way, making it symmetric, I don't really have any trouble counting. So if I'm halfway, then I know that 1, 2, 3 is going to go up 9. And so 9 is going to be right below here. And then 1, 2, 3, and then up 9 is going to put me right there. And then the next one, as we just said, if I go over 3, I go up 9. So if I go over 4, which is 1 more, I'm going to go up 16. And so 1, 2, 3, 4, 5, 6, 7. And really, doesn't matter so much. It's an estimate, but what I'm trying to, and that's a really bad drawing, but I know y'all don't really care so much, because what matters is that you are able to determine where it's crossing um, the x-axis, and that's where our points are. So we have it between those two and between those, because I know that's where it's happening. So our answers, here we have the integers. We're going to say one of them is between, what are those two numbers? -3 and -2. Between -3 and -2, and then between 1, 2, 3, and 4. As you can tell, this is not the most accurate way to solve quadratic equations. We're going to talk more about that later. I do want to talk about solve using your table and make sure you know how to use your inspires. So when you get your inspire out and you go to menu, you want to go to a graphing page and enter this part. Let me get a new color here. You're entering this right here into your equation bar. So F1 equals that, which I have done, and then you're going to press enter, but this is what it would look like. Let me go up and show you. There's F1 right there. Okay, so x squared minus 6x plus 2. All right, and you graph it, and this is what we've got. No, don't go away. Hit tab. Go away. Hold on. Wasn't supposed to do that. You can click this button right here, y'all, and it will go off, because really all I want to look at is that one right there. Okay, so this is the function, x squared minus 6x plus 2. The directions say solve by using a table. So I want to make sure you all know how to do this. And if you hit Control T for table, then it pulls up your table right there. So you can look at that as we've just talked about. I've got the next problem in there, so don't look at that right now, please. Okay, but where are my sign changes if I need to go? No, they're all positive. Okay, so so I go from 2 to -3 between 0 and 1. And where is another one? Right here. So between 0 and -1. No, right here, sorry. Between 0 and +1, it goes from 2 to -3, and then it goes from -3 to 2. So I know that I have answers between 0 and 1 and between 5 and 6. The directions want me to go to the thousandths. So when I'm on my table, if I hit menu, come on. Maybe it's not going to show me. I need to get to a different screen. Let me pause 1 second, please. Okay, I had to change the settings so that you could see what I was doing. So when I push menu, okay, and you go to your table, and you go to edit table settings, it's actually not going to give it to you. So hold on 1 second. LOL. Let's do this. We talked about that. I know one more thing. Hold on. Wrong one. Okay, apologize for that. Basically what I've decided is you can look at your table to verify things, but if you have to go to the thousandths, that would not be the best option. So I'm going to show you what to do. So Control T puts on a table, because sometimes that's the fastest way to do it. Control T takes off the table. Okay, so what you actually want to do, if we have not talked about it, is hit menu, analyze your graph. You're looking for zeros, and you're going to slide using your little touchpad. There's one of them, 5.65, and I'm fine. It says thousandths. We'll go to the hundredths. We could change that, but it's not worth it right now. Okay, you have to do it again for this one, and so you're going to hit menu, analyze graph, 0. You got to be careful to only have 1 0 in that region when you are doing it. Okay, so this one gave us Where is it? Go away. 0.345. 354 and 5.65. So I'm going to go x equals 0.354 and comma 5.65. Okay? All right, this last one real quick. How long would it take to reach the ground if the height was modeled by that function? So if I go back to my other graph, I put it in, okay? When you hit Control, New Doc, okay, you add another graphing page, or you can just go up and edit the previous one, okay? Here is the equation that I put in, okay? And I'm hoping that you know this parabola is clearly going down, but if you want to look at it, the y-intercept is at 400. And so you can double tap right there, and if you want to say, all right, I need to look at that better, so let's make it 420. And when you do, actually it's funny, that's the y-intercept, so we can make it even. Let's go this. Let's make it 500. And if you hit tab, you can go between the other numbers. If I'm going to go hit tab again, come on, there we go. That's the negative one. Let me go down some so we can see this clearly. Once you hit enter, it's graphing. So that's what the function looks like. Now, that is, it's how long would it take it to reach the ground? Okay, this is where it started because that's time 0. So where does it reach the ground? Right here, which is our 0. So I'm going to hit menu, analyze, graph, get a 0. I want this one. I don't care about the one on the other side. Now, keep in mind too, let's see if it'll let me grab that. It won't. All right, but that says 5.82 times 10 to the negative 11th. Y'all, that's 0. So your answer is at 6.72. So, going back to our equation, what am I going to answer? How long would it take? About 6.7 seconds. So, I hope that helps. If you have any questions, please don't hesitate to email me or contact me. Or ask one of those other wonderful teachers at your school. Thank you very much. Miss y'all.